Let's talk about the four big theorems to prove that two triangles are congruent. So again, remember, congruent means that they are exactly the same. And really with triangles, what it means is that we have these theorems set up that ensures that there's no other triangle that could have these same measurements and not look and have every other measurement exactly the same. So our first one, I'm going to kind of keep these on the top and then I'll draw. Our first one is called side, side, side. So we usually just write it like that. And what that says is that if you have three sides in one triangle that are all congruent to three sides in another triangle, there is no other possible triangle that could exist that would not be congruent. Meaning, if you ensure that you have these three pairs of congruent sides in your two triangles, automatically all of the angles are the same and your triangles will look exactly the same. So that's our first congruence theorem. Our next congruence theorem is side, angle, side. So this means that we have two pairs of congruent sides and the angles that are between them. Notice how the order is important. We've got two sides and the angle that is inside those two sides. Really, those two sides make up that included angle. Those are the same. And why this works is because if these two sides are the same and this angle, well, we can then figure out the measurement of this side. And it has to be the same over here. So if you have two congruent sides and the angle included inside them is congruent, there's no other way to make a different triangle with that being true. Let's do the next one. We have angle, angle, side. So this is where we have two pairs of angles that are congruent, like that, and then a side that's congruent. Now this is important because I hope it's obvious from our other work in geometry, or from your other work, that if you know these two angles, you can find this one because they must add up to 180. And we could verify then that, that all of the angles are the same. But it's also possible to take a triangle and imagine just shrinking it down and keeping the angles all the same, but making a smaller, scaled down triangle. Well, then they wouldn't be congruent. But the minute we have a side measurement, that way we've ensured, okay, we've maintained the shape, the angles are the same, but we also have a size that makes them the same. Now, there was nothing really important about this particular side that I picked. I certainly could have also picked this side. And just remember how important your order is as you go. This says it's angle, angle, side. So it needs to go an angle, and then a side. Okay, angle, angle, and then a side. But it wasn't important. We could have gone, clockwise or counterclockwise to achieve that. Let's look at our final theorem. And it is angle, side, angle. So similar to the last one, but the order is different. If we have two pairs of congruent angles, we can automatically figure out what the third angle is, but that doesn't ensure that we don't have kind of a scaled proportional relationship. But the minute we add a side inside there that is the same, then we have ensured that the size of the triangles is also the same. So it not only maintains its shape, but it maintains its size, and therefore the two are congruent. So again, if all three sides of one triangle are congruent to all three sides of the second, that is side, side, side. If you have two sides, and then an included angle, so the angle that is in between the two sides, so like these two sides and this one, are congruent to the two sides and angle the other, we have congruence. And then if we have two angles and a side outside those two, or two angles and the side between them, as I've drawn in this example, that is also going to prove congruence. Now we have one other congruence theorem that is a special case, and it is for right triangles only. Right triangles only. And it is what's called hypotenuse leg. And it says that if the hypotenuse of my two triangles are congruent and either of the legs, so it could be this one like that, a leg is just the shorter sides, or of course it could also be these two because these are also legs. Any situation where we know that the hypotenuse of my two triangles are congruent, and then we also know that we have a pair of legs that are congruent. That will also prove congruence, but this again is a special case for right triangles only. Now the one situation that is missing that sometimes gets asked about is sides, two sides, and an angle. And the reason that that is not enough to prove congruence, I've tried to draw an example here. If you have this pair of congruent sides, I hand drew them, but they're roughly the same length, and then you have this pair of congruent sides, and these angles are congruent, but obviously these two triangles are not congruent. So it really has to do with the fact that this leg can sweep out and you can still draw the triangle. You know, if you basically put a dotted line along this and just swept this out till it intersected, you would have two sides that are the same in that non-included angle, but they're two completely different triangles. So this is not a way to prove congruence. The only way to do it with two sides and an angle is if the angle is in the middle. If this video helped you with the congruence theorems, please like and subscribe. I have an entire playlist of geometry content.